I do want to set some expectations with respect to our robot. As you know, last year it was just a person in a robot suit, but we've come a long way, and it's I think compared to that, it's going to be very impressive. So should we bring out the bot?
With the development of robotic technology, Tesla's automation strategy has evolved over the years. By studying where Tesla went wrong and where it excelled, Tesla learned lessons and understood how to build an automation strategy and become the apex of the robotic automation movement, not just in industry, but also in the world. Let's analyze how Tesla became a pioneer in the robotic automation movement. Few companies command as much scorn and admiration as Tesla. When Tesla launches a product like the Cybertruck, reception is mixed. 4,444 critics see this as further evidence that founder Elon Musk is out of touch and doomed to fail as backers bought him out after a month. But surprisingly, Tesla has received 200,000 pre-orders for the new model. Compare that to the Ford F-150, the world's best-selling car in 2018, which sold just over 1 million vehicles that year. Disagreements aside, there is no doubt that the company has shifted the auto industry towards electric vehicles and achieved steady revenue growth, exceeding $20 billion in 2019. At the start of 2020, Tesla was the best-performing automaker in terms of total profit, sale growth, and long-term shareholder value. There's definitely a method to what seems crazy to many people. Tesla's recent market performance proved some skeptics wrong. By mid-January 2020, Tesla's market capitalization had reached $107 billion and surpassed German giant Volkswagen to become the world's second most valuable automaker after Toyota. Tesla's valuation now exceeds that of Ford and GM combined. If one looks at Porter's 5 Forces analysis, industries like the automobile industry seem especially immune to the threat of new entry and upstart competitors. Numerous factors that Porter identifies, including economies of scale, learning curves, access to distribution channels, patents, unrecoverable upfront R&D expenditures, and other capital requirements can serve as barriers to entry, and all of them seem to be present in the auto industry. 35 years ago, Porter wrote, "In the auto industry, economies of scale increased enormously without post-World War II automation and vertical integration, virtually stopping successful new entry. Many have speculated that even if a superior product existed, incumbents might effectively keep it off the market due to the high barriers to enter in the auto industry. One such product is the electric automobile, which has long been desired by those looking to lower vehicle emissions, but it's seen by many as being too challenging to market. Since they cut pollutants and enhance air quality, electric automobiles are a winner for consumers and benefits all parties involved. Nevertheless, it claims that because electric vehicles pose a challenge to the traditional gas-powered auto industry's profitability, economics and corporate power stop California's electric car program in its tracks. Electric automobiles don't have the same distribution and service network or infrastructure for fueling that gas-powered cars have. Using the language of potential market failures, the challenge associated with introducing an electric vehicle are as follows. High barriers to entry, such as the high fixed cost of introducing new technology and building the production capacity that incumbents already have, and network externalities associated with electric cars, such as the need for new charging stations compared to the gas-powered vehicle's existing fueling stations. It's true that new entrants are what drives innovation. This observation was by Silicon Valley entrepreneur Elon Musk, Tesla initial investor, co-founder, and CEO, who viewed all of the barriers in the auto industry as ones that could be overcome. As Musk explains, "Our goal when we created Tesla a decade ago was the same as it is today, which is to drive the world's transition to electric mobility by bringing a full range of increasingly affordable electric cars to market." Tesla's long-run success, with or without current preferential tax treatment, is to be determined. Nevertheless, within 12 years, Tesla has created one of the top-selling full-size luxury cars in the United States, and Tesla's Model S has won multiple Car of the Year awards and earned all-time top rating from Consumer Reports. To achieve Tesla's uncomprising production goals, Musk has chosen an equally uncomprising manufacturing strategy. Full automation, no ifs, no buts. The goal is to eliminate all human operators and only stop when the facility resembles an alien spaceship. The logic is that increasing the volume of speed of vehicle production requires moving from human speed to robot speed. Using first principles, Musk reasoned that if mechanisms could perform tasks faster, more consistently, and more accurately, then Tesla should aim to automate as much as possible and do it as quickly as possible. The Tesla Bot project marks a new age in humanoid robots with these groundbreaking advances, ushering in machines with enhanced motor control, the capacity to mimic human-like motions, and the ability to complete tasks autonomously. This enthralling view into the future demonstrates how these robots can transform a variety of sectors, paving the path for effective automation and the seamless incorporation of technology and human-centric jobs. Although Phoenix and Tesla's humanoid robots appear to be making rapid progress in their capacity to replicate human gestures and performance, it's clear that it is still a long shot. More than 500,000 Teslas around the world transmit data to Elon Musk's headquarters to train their autonomous driving algorithms. This data gives Tesla a huge advantage in the race to put more self-driving cars on the track. When you think of Tesla, you probably think of it as a traditional automaker. There's no doubt that Tesla is the leader in the field of electric vehicles, but the key to their success is that they are truly a technology company. Their business is built on artificial intelligence technology, and that is one of the reasons for their success. Today, one of Tesla's main goals is to make their cars fully autonomous, and they are leveraging big data and AI to achieve this. To drive autonomously, self-driving cars continuously interpret images from machine vision sensors and cameras, and then use the information to make decisions about what to do next. They use AI to understand and predict the next movements of cars, pedestrians, and cyclists. This data helps them plan their movements in less than a second and decide what to do with each movement. Should the car stay in its current lane or change lanes? Should he pass the car in front of them or stay where he is? When should a car brake or accelerate? To make cars fully autonomous, Tesla must collect the right data to train its algorithms and power its AI. More training data inevitably leads to better performance, and that's where Tesla excels. Tesla's competitive advantage is that it collects all the data from hundreds of thousands of Tesla vehicles currently on the road. Internal and external sensors monitor what the Tesla does in every situation, and even collects data about the driver's behavior and reactions in different situations, as well as data like how often the driver vehicle touches the steering wheel or dashboard. Tesla's method was called imitative learning. Their algorithms learn from the decisions, reactions, and movements of billions of real drivers around the world. All those miles translate into super smart self-driving cars. Their tracking system is extremely sophisticated. For example, when a Tesla vehicle makes an incorrect prediction about the behavior of a vehicle or driver, Tesla records a snapshot of the data from that point in time, adds it to the data pool, and then recreates an abstract representation of that scene using the color coding model, from which the neural network can learn. Other companies working on autonomous vehicle use synthetic data, such as driving behavior from video games like Grand Theft Auto, and this data is much worse than real-world data, which Tesla uses to train its AI. Musk was a software entrepreneur, and his approach to hardware was heavily influenced by agile software development. Silicon Valley essentially operates on the lean startup method. Instead of building something alone in the dark basement, the goal is to get the product into the hands of customers as quickly as possible, to understand their needs through tangible experiences and iterate on your product to meet those needs. This is ideal for software because updating the product and redistributing it is quick and easy without cost or hassle. Reid Hoffman, founder of LinkedIn and Musk's colleague at PayPal, modeled this approach when he said, "If you weren't embarrassed by the first version of your product, you would have launched it too late." For Tesla, following this approach means shortening the development cycle, foregoing production testing, and going straight into large-scale production. That is, large-scale production of an advanced product at a feasible level, in volumes 100 times larger than before, using new and untested production methods. Patient customers and the goodwill of deep-pocketed investors also played a role in their frantic invention, experimentation, and confidence to create more technology-integrated machines. But ultimately, the limitations and challenges they imposed on themselves led to manufacturing innovations that paid off by 100 times. Instead of losing faith in robots after all the challenges of conflict and integration, Tesla has subtly reshaped its approach while doubling down on automation. So that's it. Did we miss any key factors behind Tesla's robot automation movement? Comment that down. Hit the like button and subscribe for more. And don't forget to share this with your tech geek buddies.